Good day friends, today we are going to discuss about services in Kubernetes cluster. The services in the Kubernetes cluster is predominantly for a networking purpose. Let's assume that this we will take it in three ways because we have three different services. We have to explore each services, so we will go through the each scenarios and separate labs. So before that, let's just explore an example here. So I'm an end user. I wish to buy some. I'm trying to access an online store. That particular store is having a Kubernetes infrastructure. So the application is hosted on multiple pods, and the database is hosted on again a couple of pods. So as an end user, I will be accessing the front-end application. Again, in between the front-end application and me, there would be several network devices. That is separate call. But a high-level overview, I'm an end user and I will be accessing the front-end application, and the front-end application will connect to the database. So let's forget about the database connectivity, that we will discuss later. I am a end user and am connecting to the front end pod. So how do I communicate with the front end application pods? That method is called, if we enable a NodePort service, that service name is called NodePort. So if we enable the NodePort service, we can communicate, the end user can communicate with the application pods. In an enterprise infrastructure, yes, there will be load balancers. So all this traffics will be defining by the load balancers. But again, we have to configure the same scenario over there as well. But in this case, let me tell you one more thing. Here I have a physical server. So in this physical server, we have hosted two application pods, right? We have another physical server. Here as well, I have hosted two pods. I mean the application pods. So here what will happen is, in the case of NodePort, the end user will be able to see this machine. Here as well, the end user would be able to see this machine, but the pods will be running within this machine. So the end user can access this machine. From this machine, the end user can access the pod or the web application. Or in other words, the end user can access the pod via this worker node. So how do we access that? In that case, again, if we take a couple more considerations, this pod will have one IP address, this pod will have another IP address, again this pod will have an IP address, this pod will have an IP address. These IP addresses are automatically assigned by the cluster. I mean Kubernetes cluster. So no matter what is happening there, these all transactions will be taken care by Kubernetes cluster. We don't want to do anything manual. So that's the beauty of service. So what do we do is we'll create a NodePort. Like the end user will log into, we will bind, or in other simple words, we will bind one port from pod and the other port from node. So there will be a channel or a communication. So the pod and the node will communicate via that particular port. So this port, the port on the pod is known as target port. So this would be, let's assume that say that this is port number 80. Same port we can mention at the other end in the node. At the same time, the end user will connect to the similar port here. So what will happen is we have to create a binding here, something like, let me show you that. We have to create a binding in between those ports. So this port will enable the user to connect, this port will enable the user to connect to the node and via to the port via the node, and this port will connect to the node. So that what will happen is I will be connecting using the node's IP and to a specific port, and that particular traffic will route to the pod by the node. So that communication is known as NodePort. So the port on the node is called NodePort. In much more simpler way, it's my physical server, it is my pod running on the physical server, and I am an end user. I'm sorry, I am an end user. So the end user will be connecting to the node. So this port is called NodePort. At the same time, the Kubernetes will create, we will select a port in the pod. This is called target port, and this target port will be connected to the port on the node, and again this both the ports on the node is connected together. So when a user tried to log into the pod, so first the user will reach out to the NodePort, then the NodePort will take this connection to its port or the desired port, and the particular port will take this to the target port, and via it will reach out to the pod. So this communication is called NodePort communication. Assume that I have a similar setup here. So assume that I have a deployment. So this deployment is spanned across two nodes. That time what I will do? Same, for example, I have two application pods. What I will do? There also the scenario, everything remains same. Only we need to do look at is this would be the target port, and we have a port here, and we have another node port here. So the end user should go to this particular IP address, then this IP address and that particular port number. It will take him to the port, and from there it will take him to the target port. From there we can reach out to the next replica of that particular pod. So how do we do this? If we have, how the Kubernetes cluster will identify this? Using labels and selectors, the Kubernetes cluster is able to identify that where and all the pods are present. So this NodePort service will impose to those particular pods, so that the end user can see, the end user will be able to decide the node IP address and that desired port. So using that particular IP address and that particular node port, the end user can access the pod. So let's explain you with the example. This is this much only the theory. So let me create, deploy. Its name we will call it as nginx app --image nginx. We created it. So kubectl get deploy. Okay, there's one one deployment called web app. Let's delete that. kubectl delete deploy web app. Now kubectl get deploy. Alright, there is one deployment. That one deployment is up and running. Now let's understand much more. kubectl get deploy replica search pod service. If you look at here, we have a deployment called nginx app, and we have a replica set called nginx app hyphen so and so, and we have a pod called nginx app. So this image is nginx image. Now how do we create a service. If we put this minus o wide will give you that particular pod IP. This is the pod IP. Now get deploys hyphen show hyphen labels. I'm sorry, there's a typo. App equal to nginx app. So here we have two options. We can create the service via imperative way, and we can create the services via declarative way. Now first let's create the service via declarative way. The declarative way, we have to rely on the YAML file again. Let's create that. Kindly note that the app equal to nginx app. That's the only thing should be in our mind before creating the service because we have to filter the pods. Vi service.yaml. I'll pull it here. The API version for service is v1 in Kubernetes. Kind is what kind of objectives are we creating? It is called service. Metadata. Here we have to mention the name of the service. We can say nginx -svc. Now next is spec. Here it is type of the service we are selecting. It's not port. These all are character sensitive, so should be very careful while giving all these things. Now we have to give ports. Ports, there are multiple. We will be dealing with multiple ports, so we have to mention each and everything. I mean, we have to mention it in an array. That's called target port. Let's say 80. I mean, it will connect to Kubernetes that nginx port number 80. Let it connect to the server port 210. Simply we can give anything. NodePort. I'll give 30,008 because from 1 to till around 30,000 the ports are already allocated. I mean, most of the ports are reserved, so there may be chance for conflict, so that we are selecting a huge value. Now we have one more parameter called selector. Selector will filter the label. So here it is, app colon nginx, I guess. That's it. sorry, Nginx app. It is cat service YAML. We have to edit that. Let's create kubectl get deploy comma svc minus provide. I'm sorry, this typo is repeating again and again. If you look at it, here we have a NodePort and the port number is 30,000 and the node port is 30,000 and port number is 210 and the service has been established. Now how do we come to know that whether we have the setup is working or not? Simple thing we can do is call http:// what is that port IP? Mm-hmm. 10513. So call http://10513:80. It's working fine. Now within the cluster, if we access this within the cluster, we can do this way. Using this IP we can access it. Let's try that. What is happening? 300,008. So whether 80 is working? So here our so it's deployed on node 2. We will do one thing. Let's create another instance. It's in node 2. Node 2 in the sense 192.168.0.132. So we will do this way. Code http:// the yes, so it worked. If you look at here, what happened is 192.168.0.32.30,008. I'm able to access the Nginx port from here, I mean node 4. So how the traffic has gone is, first it has gone to, let me go back to the Excel again. First, here I am an end user. Yes, happy ending it is. From here I connected to the physical node. So I connected to the node port 30,000. So node port, it has forwarded that request to its port on the node. Then from the port on the node, it has further forwarded to the target port. The target port is at the pod. So we have received a clear-cut connection from end user to the pod. So we check this way. Suppose if we have 100, let's explain in that way. Let me go here. So kubectl get deploy. Now kubectl get pods minus o wide. I'm sorry guys, this keyboard is, I'm pretty much familiar with this 15-inch laptop, whereas the laptop which I'm using is 16-inch or 17-inch. The keyboard size is quite large, so the key distance is somehow creating problem. So if you look at here, node 2, the pod is running. Let's kubectl scale deploy. Deploy. What is the deployment name? Nginx app -- replicas equal to 10. Alright, it is scaled. Now kubectl get pods minus o wide. The ports are creating on node 3, node 2. Alright, so what will happen here? kubectl get nodes minus o wide. So node 3, new port has been created at the node 3. So what we will do is, we'll go to a newly deployed node which is not part of the Kubernetes cluster. From there we will try call http / that particular node IP / 30,008. I'm able to access now. So this is the way we do it. But in real life, again, if you ask me that do you publish this particular IP to everyone, that's a big question, $1 million question. In that case, what I will do is, if we have three nodes here, we will create a node port here. So the port will be same only. 30,008 here, 30,008 here, 30,008 here. But the three IPs will come into the picture. So what I will do is I will place a load balancer here, and these sessions I will connect to this load balancer, and this load balancer will share the session based on the traffic. That way we can do it. That's it, the node port. So in our next video we will come up with, or one more thing we will do as part of cleanup. kubectl scale deploy nginx app -- replicas equal to 1. So all the ports will be deleted. kubectl get ports -o -oy. It's now again back to node 2. So if I try to access, let's say if I try to access from here, if I try to do that, 31, okay, 32, 33 is the node 1, 32 is node 2, 31 is node 3. So we will do kubectl sorry, (33), 32, 30. Sorry, 30 is no more in the network. 31. Nginx is running. Now we will do one thing. kubectl. We have scaled the application to replicas 1, right? Now let's put it 0. Now what will happen? Nothing. Again nothing. Nothing. So here the service is already bound to that particular node port. I scale again. Accessible. It's accessible again. It's accessible. So that's it, the node port. So we will access it from any of the nodes to that particular port. So we will be able to access the Kubernetes cluster I mean the pods hosted in the Kubernetes cluster. Same way we can do that. So these transactions are being taken care by Kubernetes cluster via its service objective. So that's it from my side. Thank you so much, and in the next video we will discuss about the next service called cluster IP. Thank you so much for your time. Have a great day. Bye.